Hello and welcome to Saurav's classes. Today we are discussing the Indira Gandhi University MSc entrance paper. In this question we are told that there is a function fx which is defined by ax plus b over x minus 1 into x minus 4, and this function has a local maxima at the point 2 minus 1. Then find the values of a and b. Now first of all we have to understand what do we mean by local maxima and local minima. Now if you look at the function, you can understand that the function is of the form some function of x over some function of x square. So this is of the form ax by x square plus dot dot dot. So that means it is equivalent to the function 1 by x, some form of 1 by x, and the function 1 by x or variance of 1 by x will have a curve like this or a curve like this, where this point will be the local minima and this point would be the local maxima. So this is how the curves will behave. Now obviously there will be variance of that, and it depends on the values of a, b, etc. But this is the concept of local maxima and local minima. Now let's see how we can find this out. So in order to find the maxima or minima, we have to take the first differential of the function and equate it to 0. So f dash x is equal to 0, which is equal to differential of ax plus b, which is a, keeping the denominator as is, so x minus 1 into x minus 4, minus keeping the numerator as is, differentiating the denominator, we get x minus 4 plus x minus 1 over x minus 1 whole square into x minus 4 whole square. Now since we are equating this to 0, so the numerator will become equal to 0. So we can simplify the numerator now. So the numerator becomes equal to a into x square minus 5x plus 4 minus ax plus b into 2x minus 5. So this can be written as a into x square minus 5x plus 4 minus 2a x square minus 2bx plus 5ax plus 5b. So this is equal to ax square minus 5ax plus 4a minus 2ax square minus 2bx plus 5ax plus 5b. Now here we can see that the terms minus 5ax and plus 5ax will cancel out. So we have the rest of the terms, which is ax square minus 2ax square. So that is equal to minus ax square, and then we have minus 2bx. So minus ax square minus 2bx, and then we have 4a plus 5b plus 4a plus 5b. Now this whole thing is equal to 0, and this happens when x is equal to 2, because the point at which the maxima happens is 2 minus 1. That means the value of x is equal to 2. So we put the value of x equal to 2 in this equation to get 0 equal to minus 4a minus 4b plus 4a plus 5b. So that means minus 4a and plus 4a cancels. So 5b minus 4b, that means b is equal to 0. So this is one value that we get for b. And now we will put the value of the function itself as minus 1, which is the maximum value of the function at the local point. So therefore we can write this as minus 1 is equal to ax, which means a at the point x equal to 2, so this is 2a, plus b is equal to 0, divided by x at the point 2 is 2 minus 1 into 2 minus 4. So therefore minus 1 into 2 minus 1 is 1, and 2 minus 4 is minus 2, into minus 2 is equal to 2a, or a is equal to 1. So we get the values of a and b as a equal to 1 and b equal to 0, and we can see option 2 gives us a equal to 1 and b equal to 0, which is the correct choice.